All right. It seems now it's working, but let me see. Yeah. All right. Okay. So now we are live on both, I think, on YouTube and also here on Facebook. So you can directly follow. So I'll just make a small revision from what we did about what we did last week. So last week I was showing you how to install R and how to set up a working directory. There are many different ways of setting your working directory because it's really important, because you need to set up where your files are. So I show you some how to change it and how to locate your files. For example, here and the package. I mean, we did something. We did some tricks in here under RStudio and how it looks like, and I was also showing you a little bit about creating data, some fabricated data we were creating, sex, age, education, height, weight, and if you remember, we were calculating PMI, and we were concatenating variables to make a data frame. Maybe I can just rerun it, and then we can have a look, and then we'll proceed to our today's session, which is really important. I mean, the loops in R, for loop, while loop. I will be mainly talking about for loop. I will not talk much about while loop, because to be honest, I mean, I haven't used it much, but you just need to know it. I mean, if you're let's say if you're RStudio, I mean, if you fail to install a package, you may just use it. Otherwise, most of the time you record or you assign new variables using a package. So this is for, and while loop is mainly to, I mean, to practice and to know how the packages work. So I mean, one thing that I didn't tell you probably is like when we say R is open source, it's open source. Open source means you can the distribution, and you can download it for free, you can install it for free, it's open. At the same time, all the functions and the packages provided in R, they are also free. I mean, they are also, you can even manipulate them. You can change them by yourself. Let's say if you want, for example, if I show you library dplyr, for example, I mean, you can this is dplyr, and then if you want to see filter, how it works, filter, for example, you can use filter, and then you see there was some key that you can see how, so this is how the dplyr function is written. So this is how it's written. So if you want to change, you can change it depending on what you need, but when you save, you have to make sure that it's saved differently. Otherwise, you will mess up the functions of the package. So I mean, that's really how open source is. I mean, you can change, at the same time you can use it. It's all free. So that's what I wanted to say. But today, before we talk about today's session, I think let me show you some tricks. Let's say if you want to know the number of rows in a data frame, you have to use n rows like this. And if you want to see the number of columns, you can see n calls. You can use n calls. Let's say I already have a data with 6 observations and 7 variables. If I use n calls dot a, I will need to see dot a. That means n call. I think, dot a. Then you see 7, because I have 7 variables. But if you also type n row, dot A, and you see 6 observations. You can it's just to have a quick overview of how many observations that you have, how many variables you have, and so on and so forth. Maybe the other thing I want to say is indexing. Indexing is to know which observation is located where and which variable is located where. So if you want to see, indexing in R, it started with 1. In other languages, you may have from 0. So it's R starts counting from 1. So let's say in my dot A, let's say if I want to say dot A, let's say if I want the first observation. If I want to view the first observation, I can write like this, and then I can have the first observation. So this is how the first observation looks like. But if I want to see the last, let's say, the first one written here is the case or the observation or the rows. But at the second one, this after the comma is the column. Let's say if I want to see this, that means I will see age. So it will be 23. So I can just run this, and then you have 23. But if you see 2, that means it tells you which variable type it is. It's like second observation actually. No, it's for age variable, because if you remember, your age variable is like this. So it gives you all the values of the age column. Yeah, so before we jump, I need you to know all of these things. We jump to the loop. I need you to know all of this, and then the other one that I want to show you is like logarithms, functions, like mathematical calculations. Let's say if you want to multiply numbers, you can just say 1 times 1 or 1. Yeah, all the multiplication signs all the multiplication, or all these arithmetic functions, they all work here the same way as you may type it in other language. In your Excel or anything else. But if you want to use a log, then for logarithm you have many different ways of. That's like log 2. This one is a natural logarithm, and this is log 10. So if you want to check log 10 of 10, that means it's 1. So you can also use like that. And then let's say if you want to see number of objects that I have created in my environment, that you can simply type ls and then run it. So that means I have all these objects in my environment. Like I have age, I have education, and dot A, and so on and so forth. And then the other one, sometimes you may have, your RStudio may be busy, you may have a lot of objects, and then your memory might be busy. So sometimes you may need to offload your garbage. So there might be garbage being collected in your environment, which makes it busy. So then you can simply use this garbage collection, and then you see garbage collection, GC. And then it clears up unused files. They will still be on your environment, but it will not keep them in a sort of temporary memory. But it will still keep it. You can still use it later. You can call it, but you can periodically call. If you are running, let's say, massive data, you can simply use GC, and then you still can have. You can offload your garbage. Then sometimes you may also have like error, like your memory. Let's say you are not. It may say that you don't have enough memory to run this. So that means for that you need to see memory limit. And then see, for example, for me, I have memory limit 8034, but I can change it depending on my run. So you can just size, then I can simply use, let's say, 10, I don't know, something like this. But it will give me this much amount. And then you see yeah, now my memory limit is this much. It's the number of columns and cells that I'm allowed to have in my R. I think that's what it is, but I don't really know much about this. And if you want to delete an object, you can simply use rm. Yeah, rm. And then let's say if I want to remove that, I can just use rm dot, and then it deletes it. Let's say let me create an object x equals 1, or x x is no, it's not typing, x c 1 2 3, and then I can simply remove it. Remove x, yeah, it will be completely deleted. And that's not possible to bring it back unless you have to go back to your history and then you see what you did, and then you can bring it back, of course, by seeing the history section. So these are the things that I want to show you. After that, I want to go directly to my or today's session, which will be about loops. Let me bring this. I have a small PowerPoint to my yeah. So loops are really very important ways of automating your code. So a loop is a way to repeat sequence of instructions. So if you have many different sequence of instructions, you can automate it, under certain conditions. So you write your code. Your code may need repetition, so it may need to go through each, let's say, each observations or each variable, and then it may need to recode, or maybe to multiply, or any kind of logical, any kind of mathematical or logical expression or condition. Then your loop function will automate that process instead of going one by one. So it asks a question, and then it changes. It gives you the output. So there are many loop functions. You have for loop, the while loop, and then the if-else function, and then you have like repeated nested for loop. Like the for loop may be nested with other, let's say, with if-else, or with while loop, and so on and so forth. And then at the end, you also have like apply functions. I will not go through the apply ones, but I will show you mainly the for loop, because that's actually what you need most of the time. And usually you may not need it, because you mainly work with with a package, but if you are interested, I can also show you some of these. So it's you want to iterate your codes over and over again, so it helps you to iterate it. Then you have the let's say these are the way the for loop is written. So you have for at the beginning, and then you write in this bracket your expression, the one you want. What does it need to do? Let's say you may start like I in 1 to 100, and then you say, okay, print even numbers. Or you may say for I in 1 to 6, print x squared, like something like that. So what it does is like, it asks question for each item in a sequence. So it asks a question. So it asks the question, and then it says if it is yes, let's say, and then it goes to the loop, and then it goes over and over again. When it's complete, then it will exit the loop. That's how it worked. But we will see that in a code, which will be easy. So let's say if you want to create like between this, let's say you have x between these values of x. So you can see for val in x, so that means val is each individual values in this vector. And then you see if val divided, this is like it's called modular operator. So if you use, I didn't tell you about this actually, but if you use this, and then if you have like equal 0, which means the number is even, or it's divisible by 2. If you use 3 and if you have 0, that means the remainder is 0. Otherwise, if the remainder is different, it will consider it as 1. So it's not divisible by this number. Let's say if you use 5, it's not divisible by 5 if it is not 0. But if val divided by 5 equals 0, then let's say 3. If you make 3, for example, if val or if each value in this x, if it is divided by 3, and then if you have 0, then it will give you all these values, 3, 9, 6. So you have 3 different values of x that are divisible by 3. Yeah, so the way you write it in your code is like this. For I in 1 to 100, let's say for I in 1 in 100, so you close this bracket and then you open curly braces and then you write your expressions here, your what you want to do here. Maybe you want to square a number, or you want to identify the even numbers, or you want to identify numbers, prime numbers, let's say, or you want to calculate a factorial, and so on and so forth. And then you hit it, so it will go through and automate it. Yeah, this one you don't need it. So loop will execute a block of commands until the condition is no longer satisfied. So until the condition is no longer satisfied, it will go over and over again until the final answer is no. So when it's no longer satisfied, then it will exit the loop and it will complete the process. The while loop is also, the way it's written is it's similar. So you start with while, and then you start with test expression. You have the curly braces, and then you have your statement, that what you want to do. Let's say while x less than 6, so you start with x, let's say 1 to 5, and then while x less than 4, then let's say add a number from each value. Then it will give you every number by adding 1, and then until the last number, which is 4, is reached, and then it will stop the process. So let's say you have I, you start I with 1, and then while I less than 6, print I. So that means it will print 1, and then it goes through I plus 1. I plus 1, it continues until 5, because you mentioned that I less than 6, and then when I is 6, it will stop the process. Yeah, I think it will be better if we look at it in simply in code. And then you have another loop function, that's repeat loop. So a repeat loop, maybe it's better to go back in R, and then maybe have see directly in how it looks like in RStudio. Okay, let me open this. Let's say you want to automate 4. So you can, the way you write it is from I in 1 to 6, let's say. From I in 1 to 6, and then you start with your curly braces, and then you enter it so that it looks nicer. Then you simply write print, let's say I square, which means I square like this, or I simply like this. In both ways, it will square a number, and then it gives you 1, 4, 9, 16, 25, because it's squaring every number. So, but if you want also, if you want something like this, I factorial. I think factorial. No, it's not like this. So you can write factorial. Yeah, you have factorial, and then I. Then it will do everything. So it's giving you for each value, it's doing 1 factorial, 2 factorial, 6 factorial until from 1 to 6. Yeah. And then let me say you can also do this. Let's say what you can do is you can also print this, and then I can paste. Paste is another command. and then you can say, okay, I, let's say you can string concatenation the factorial of I of, and then you say comma I is yeah, something like this. Then you hit enter. No, sorry, here. Okay, paste. I must have forgotten one bracket. Should be factorial I. Okay, I have one bracket, two. Yeah, it should, now it should work. So you have like this. The factorial of 1 is 1. Factorial of 2 is 2. And then it goes over and over again. Let's say you want to identify, okay, you want to identify even numbers for I in 1 to 10, for example, 1 to 10, and then, no, 1 to 10. Then you write your curly brace here, curly brace, and then print. You can paste again. What you can paste, no, not print. So you can write. Okay, if no, this one we didn't reach here because that one is written with if else. So let's say from I to 10, then print I divided by 2 equals 0. I'm not sure this is right. No, this is not right. Okay, let's say yeah, I mean this one is telling me there are numbers between 1 to 10. There are even numbers, so that's why it's telling me true, but I don't want this one. So, and then you may say print I divided by 3, for example, from I to 1 to 10. Yeah, and then it divides every number from each. And then you may also want to do something like this. I want to increase the yeah, so then you can have a clear view. Okay, and then you may also say x is numeric 6. Maybe you can, let me give you another example for I in 1 to 6. Then curly braces, start with curly braces, and then you say print I square. Then you can also print another one. Let's say if you want, you can also print C concatenate I with I square. So this one should give a nice result. Yeah, so it's giving me, first it's printing the I square, and then the second one, if I use only this one, let's say if I remove this, turn this off, I will, okay, yeah. If I turn this off, it should work that way also. Yeah, okay, so it's giving me I square, but if I turn this off and then print this one, it will be it's concatenating the same way as I did like paste, for example. I mean, paste may not work because I had maybe it works, but let's see. Yeah, it works, but paste is mainly it's giving it this kind of signs. It's making it a string, so it's like the square of 1 is 1, 2 is 4, but you can use strings like this, the square of and then you can close this I, then here it's just to make it like a proper sentence, is like this. Hit then you have this kind of output. Maybe you can, what the next one is, you can loop, I mean you can nest if-else statements within the for loop. Within the for loop, you can nest it. That means, let's say for 1 to 6, I want to say, okay, if the number is odd, then I can write odd, it's odd. If the number is even, I can write this number is even. So that's what I want to do. For I in 1 to 8, for example, then you have like this. You open these curly braces. If, you write with if, and then if is also it's the same. It follows the same kind of structure. So you write if, and then you open a bracket. So you start modular operator. Let's say even. That means if even it's 0. That means I modular 2 equals 0, and then you open your curly braces again here. Then you say print paste I, then you write I is even, something like this. And then you go to, because you already started if statement, then you can also start else. You can write else print else. You don't need another expression here, but you can also write it, but paste, and then I say I is odd. Yeah, so if I do this, if I run this, it will give me like number 1 is odd, number 2 is even, number 3 is odd, number 4 is even, something like that. So you see it. Oh no. No, okay, here I made a mistake. For I in 1 to 8, this is what I need to write. Yeah, so 2 is even, 4 is even, 6 is even, 8 is even. But it's not doing printing. Yeah, I need to write print. So there is an error in my code. So I need to write print. Then everything should be okay now. For readability, it's better to write it this way. Like every time you have these braces, you need to close it. I mean, like you need to enter your key, so then it will look something nicer. Yeah, so you see something like this. 1 is odd, 2 is even, 3 is odd, 4 is even, and then it goes over and over again. And this is if you want to identify odd and even numbers. But we can also do something like this, like identifying prime numbers. Let's say prime numbers. What are prime numbers? I think prime numbers are if a number is not divisible by anything other than, I mean, 1 and itself. So there is nothing which, let's say you have number 13, number 19, maybe number 5, number 3. I mean, these kind of numbers, they are prime numbers. They don't have any, you cannot divide them. They are indivisible. So to do that, what you can do is for I in, let's say, for I in 1 to 10, for example, and then I will open my curly braces. I am going to identify the, I mean, my prime numbers between 1 to 10. What are the prime numbers between 1 to 10? So I can say for I in 1 to 10, if, then I will, I'm nesting if function here. So if I modular 2, and from modular 2 to I minus 1, which means like, let's say if you have 13, if it is a number, I mean 1 and we know that a number is divisible by itself. Let's say if you have 13, I mean, you know that this number is divisible by 1 and itself, 13. So then what you need to do to know is whether the number is divisible from number 2 until the digit, I mean the number which is one step behind, like that means 12. So that's why we need I minus 1 here. Otherwise, if you mention I, then it will not be, it will still be divisible, because it's a prime number is divisible by either 1 or sorry, or 1. So that's why we need this. If I is divisible by 2 until I minus 1, then for that we need to open our curly braces, and then you write print paste. It's just I want to make it a sentence, so that's why I need paste. And then I can write I then is even number. Then you can close, you already close it here. Then I go to the next statement, that's else print paste I is prime number. I is not prime number. That's what I wanted to say, number. Okay, so if you run this, it will go through each step from 1 to 10, and then it gives you which numbers are prime and which numbers are not prime numbers. Okay, so it's saying 1, 4 is, no, I made a mistake. Oh yeah, here I need to say 0, because if the number is divisible, then the modular operator will be 0 here. So if the number is divisible by 2, it will be 0, and then every number between 2 and then until the last like one, just one number before your number here, between 1, I mean from 1 to 10. Let's say if you have 9, that means from 2 to 8, and then it goes every step, and then it gives you if that number is divisible within this range. This is range, that means it's from 2 until the last, I mean like I minus 1. Then it gives you whether the number is prime or not. Yeah, so I mean this one has some kind of warning, but it's ignorable warning. So it's giving you 1 is prime number, 2 is not, 1 is okay. It's again it's producing an error. It's opposite. Yeah, this should be prime number, not, because if it's 0, that means no. 1 is not prime number. Yeah, that's right. Yeah. The output is right. So you have 1 is prime number, 2 is not prime number, 3 is prime number, 4 is not prime number, and then it goes over and over again until it finish the last step, which is 10, because we instructed it to find out the prime numbers until number 10. So 10 is not a prime number. You may also want, let's say, another calculation, maybe, and let's say you want to find out the square of a number, and then if the square of a number is let's say no, it's like from 1 to 100. Sorry, from 1 to 100. Let's say you want to say from number 1 to 100, and then you can say which of the numbers are with square roots. If you, let's say, square root of 81 is 9, that means I'm going to identify the numbers from 1 to 100 where the square root of a number is just integer without any decimal point. That means I want to identify 9, 64, and then what is it, 16, yeah, all these kind of numbers, I want to identify them. To do that, what I can do is I can simply let me drag this a bit, and then maybe I can do something like this. For I in 1 in 100, then you can open your curly braces again here. If square root of, now you can start, square root is like written like this, square root in R, square root of I, then you can write 1 equals 0, which means it doesn't have, I mean, 1 is, if you, let's say, that means it doesn't have any digit. I mean, after the 16.0 or something, I mean, 16, let's say if you square, let's say if you do square root of 3, you have this kind of digits. So if you say, let's say, if you add something like this, it will be something like so. So it's giving you every digit, yeah, every digit after the square of a number. But if you give something which is not, let's say 64, then it will give you 0. That's why we need to, first digit is 0. That means this part, I mean this one. Let's say if the first digit after the square root of a number is 0, then you want to give it a name, or you want to print it in a way. Let's say print paste the square root of I is square root of I. That's what you want to print. And then else if you want to like write multiple functions, you can write else if it goes over and over again until you are done. But you can you need to know this. Then else if square root of I square root of I divisible by 1 equals false. No, 1. Let's say not really 1. False. Yeah. Then you can. No, it's not different from 0. That means we want to print. Let's say, let me take this one. This is not integer. Maybe we can is not integer. We can just type like that. Is not integer. Let me close this quotation mark here. So, and then let me count the number of brackets that I have. Okay, sorry. Print paste. The square root of I is not. So I have 1 bracket, 2, and then I don't need anything else. Then I will need to close my curly braces. Then it will be all right. Else if I also need to open the curly braces here. I forgot them. Hopefully this will work, but let me see. Okay, there is an error. Okay. For I in 1 in 100, if square root of I equals 0, print paste square root of I is square root of yeah. Okay, this doesn't seem to work. Okay, for I in 1 in 100, if the square root of I divisible by 1 equals 0, that means the number is a whole number or like integer. Print paste the square root of I is square root of I, else if square root of I divide by 1 equals not equal to 0, print paste the square root of I is not integer. There seems that we have one error, but let me check. We have one curly brace here which is closed here, down here, and then another curly brace here, another curly brace here, then one curly brace here, one curly brace here. Okay, and then I have the last curly brace which is open at the very beginning. Maybe let me, yeah, now it's working. So it's we're correct. So it seems from 1 to 10. So it gives you the square root of I1 is 1. The square root of 2 is not integer. The square root of 3 is not integer. But the square root of 4 is 2. But we can also add something. It is integer. It is integer. Something like this. Then it gives you the whole thing. No. Something like this. Yeah, if the number is integer, so it gives you this kind of structure. I mean, it's going from each number, it's squaring it. Yeah, I mean, a square, it's a radical, I mean, putting it in the square root. And then if the number is whole number, if the square root of that number is whole number, then it's giving you that output. But we may also want, let's say, print only even, and if you pass them into square root function, then they are even. So that means we are going to identify, let's say, if you have a number from 1 to 100, that means we want to identify numbers like this. We want to identify 4, for example, 16, what else? Like 36, all these kind of even numbers. So this is what we want to do now. So for that, you can do like this. For I, let's say for I in 1 to 100, then you open your curly braces, and then if square root, if you open a square bracket, I mean the bracket, and then you again open I, because you want to iterate, you want to start from each observation, and then that means, and then you want to identify the even numbers, that means you use a modular operator, and then if you divide by that number, and if the remainder is 0, that means the number is even. So then you can use this curly brace, and then you can use print, paste, or you can also use C, but I prefer paste because I'm using a string. String in a sense, I'm using like sentences, like the square root of I is, again is, I need to put it in a string assignment, and then square root of I. Yeah, so the print the square root of I is square root of I. Then I can also say which is even. So if I run this, it will give me all the numbers between 1 to 100, and then it will square root all of them, and then it gives me only the even ones. The even ones. Oh no, there is not sufficient disk space to continue recording. Okay. I hope you are still there, but yeah. Yeah, so you see, I have this kind of answer. So it is going from 1 to 100 for each of them, from 1 to 100, and then it's asking that question. So it squares the number, divide by 2, because I want to see the square root of a number, whether it's odd or even. And then if the remainder is 0, then it gives to this. Otherwise, it will skip it. So you have print paste the square root of I is square root of I, which is even. Otherwise, it will just leave it. Yeah. Maybe we can also add something like this. Else, I again have another error message here in my. Okay, let me stop this bug here. Yeah. Okay, now it should be fine. Else if let's say if we want to say square root of a number that is divisible by 3. Then for that you can use 3, you square root a number, and then you divide it by 3. If the remainder is 0, then you type, you multiply, you say, okay, let's say I use this, and then I can simply paste it here. The square root of I is divisible by 3. That's what I want to type. I is divisible by 3. And then if I want, okay, I need to remove this quotation mark here. But if I want to add something more, maybe it's better if I put this down here. And then I can also add else if. Let's say if the number is divisible by, I don't know, 5, for example, or maybe 9. Yeah, I can type 9, divisible by 9. The square root of I is divisible by 9. So it will give you all the numbers, unless they have some coincidence that one may include the other. Yeah. So it gives you the square root of 4 is 2, which is even. The square root of 9 is divisible by 3. The square root of 16 is 4, which is even. The square root of 81 is divisible by, okay, I made a mistake here. The square root of 9 is divisible by 9, and then its square root, and then its square root is 9. You can also type and then its square root is, yeah, let me put this is within the block of that string. Then I can simply run it. If I, yeah, can simply run it, and then you can see all my, yeah, all of this. Okay. Then okay. The next one that I want to show you is okay. Let's say, okay. Let's say we want to identify, if you want, maybe we can also make it larger, because larger, and I mean we can combine it with the end. Let's say for I in 1 to 10,000, let's say 1 to 10,000. And then for I, it's I'm just repeating these examples so that you can really master this for loop. For I in 1 in 10,000, if let's say square root of a number I modular operator 2 equals 0, and let's say you want to combine it with something, and the square root of something I divisible by 5, let's say equals 0, that means the number is divisible by 5, and then you can string, you can type this, then you have here, let me write this, then you have print paste, the square root of I is square root of I, which is divisible by 5. And then everything is there. You have the last, this one, I mean the curly brace is closed. You make sure that everything is fine, and then you run it. Then you have everything. I mean, I have the output for each. I mean, these are like from 1 to 10,000. These are the only numbers that are the square root of them is even and then divisible by 5. That's 100. The square root of 100 is 10, which is divisible by 5. The square root of 900 is 30, which is divisible by 5. The square root of 10,000 is 100, which is divisible by 5. So it gives you, it will iterate for each step or for each number in within this range. And maybe the next one, maybe let me show you. I think let's go out from this for loop and let me show you something. Let's say this is my string. This is my string. Let's say if I use, this is my string. If it is type like this is my string, and I like it. For example, if you type like this and you have this and you want to count the number of characters, let's say, or you want to split them, and let's say you want to split them. So for that you can write for char in string split A, and this is a pattern. I mean, this string split is coming from string R, function. You can install it. I'm not sure it's part of the base R, but maybe you can you need to install it. So what you can do is like for char, for every character in string split A, and then the pattern is a space. That means I'm doing it a pattern. Like a pattern is a space. There is a space between each word in this string. So if I run this, it will split then the words. Like you have this is my string, and then I like it. So it gives you this output. But if you want, you can also do, let's say, you want, because the way it's written is not really it's not correct. So sometimes you may have in your data, for example, you may have mail is written like this, other time like this, other time mail. You may have this kind of writing in your data. But to make it uniform, you can just take this and then you take string lower, say lower. It should work. String. Okay, string lower. I think I have a string lower, so that means it's in lowercase. So it should be string to lower. Okay, string to lower A. So if you write this, it gives you like this. So sometimes it might be advisable to change the way your variables or the values of the variables are stored in your data. We will have a look at that maybe in the next in the future. So then it will be possible for you to let's say to see male, because male and males, the way they are written are different, but R doesn't consider them they are similar, but you can. So to make your computer able to identify that, you have to mix them in a similar, in the way that they are written similarly. But if you reduce this pattern, like no space, that means it gives you every character in there. So you see it's giving me, I have T, H, how many times, I mean I can count them, and then you have all the spaces, the capitalization, the small letters, yeah. And then maybe I can also do string, let's say lower, string to lower, maybe something like that. And then you have like this. Yeah, so every character in my string is changed into yeah, lowercase letters. Okay. And the next one would be the while loop, but if you want, we can also do the while loop. So x, maybe x1 repeat, this is the repeat loop, and then you have print x, then you go to okay, print x, not really this one, this is not what I want. Okay, okay, let's say in our dot, for example, we can do this because we already have data, or say if we do this for I in one n row, that means a number of rows in our dot, print paste the person with BMI value of dot BMI I is, yeah, something like that. We can go from each observation and then it gives you the value. Let's say the person with BMI value of 24 is female, because you have we have in our environment we have dot. So you see it's like it's going from each observation, and then it's like identifying which observation is what. So it's like the person with BMI value of 24 something is female. But we can also remove this all very long number. What you can do is you can use round. So let's say round, yeah, maybe to 1 digit, maybe, if you want. And again, here again, we need to see, no, we don't need to round here because it's a string, 6, it's not a numeric. Yeah. So that means it's giving you the person with BMI value of 24.9 is female. Then maybe I can show you R has empty cars. From empty cars data, I want to show you how to record. Let's say a numeric variable into categories, let's say, without using any package. I mean, you can use it with dplyr, you can easily do it, but we can also use it with, we can do that with just using for loops, for and if else. So, so I will just go to empty cars. So empty cars is a car dataset. So it's part of R. So if you do structure empty cars, and then you have this kind of data. So the data empty cars, it has miles per gallon, the cylinder, and then this HP, I think the capacity of the car, horsepower, I think, and then it's, I don't know, the weight, the cubic, and all of these values. So if you see, maybe we can have a look. let's say histogram empty cars HP. So if you do this, okay, plot error in plotting, figure margin too large. This is not nice behavior. Doesn't look right. Okay. HP. Oh, okay. Yeah, anyway, I want to divide empty cars HP into some kind of categories. So without using any variable. So if you see, I want to show you the distribution of empty cars, but if we can also use summary. Let's say empty cars HP. So you have the mean is 52, first quartile 96, median, that means second quartile is 123. Then you have until 335. That's the maximum value of your empty cars data. So then, if I want to categorize them, let's say HP has, as I said, has these values, but I want to categorize it into, like, if the value is 200 and more, I want to assign it as low, as high. If it's less than 150, I want to assign it as, let's say, as low category. Between 150 and 200, I will assign it as medium. So to do that, you can do is, it's really it's very easy to do it in dplyr, but if you want to, if you don't have any, but it's nice to know them. It's nice to know because it's a bizarre way of doing things. I in n, so I can use from n row to empty cars, and then I can open my curly braces. Then you can say if empty cars, I close my bracket, I open my bracket, empty cars HP. Then because I want to iterate for each value with an empty cars HP, then less than, let's say if it is less than 150, that means I want to assign it to something. So that means I need to open my curly brace, which means empty cars HP. Again, I need to iterate it for each observation. That means, and then I want to assign it. That means I need to call it low. Then I go to the next iteration, which means I need to use else if empty cars, again empty cars HP. I want to iterate it, so I need to use I, and then let's say if it is greater than 100 or equal to 150. Because I say less than 150, I'm now using greater than or equal to sign, and then I can concatenate this with end. Let's say I need to connect it. So if empty cars, if a horsepower is greater than 150, and then if empty cars, again I need to use empty cars HP, then you have I. That means I need to use again less than or equal to 200. Then I need to give it a name. I need to record it into something else. So for that, I need to use empty cars, again the same way here, but I will just change it into medium. So I will use empty cars, and then this one should be medium. And then let's say this one should not be this bracket. Instead, it should be the curly brace. So I will need to use this, but I want to delete that and then paste the other one here because I already wrote the other part of the code. Then the last part, else if, because you can, I said you can use multiple else if statements until you are finished. And then I can simply copy this and then replace it with greater than 200. So I don't need this and, instead I can use 200 and then delete the rest of the code. And here, yeah, then you can have, then I will need to open another another thing like this because I want to assign it as high. So you can say, I already opened that curly brace, so and then I say high horsepower. Then this means I'm recording the HP, but I need to give it a different name. So that means because it's giving a different value, otherwise it's replacing my original variable. Instead, I would give it a name. So this I shouldn't have forgotten this. So then I need to replace all this HP because I want to. That means what I'm doing now is I'm asking question whether empty car's HP is less than 150. If yes, that means I'm opening a new variable that's called HP categorical. HP categorized, and then I'm going for each observation. Then if it is less than 150, then it will be assigned as low. If it is greater than or equal to 150 and less than or equal to 200, then it will be assigned as medium. Then it goes again and again. Then if you run this, I hope everything is okay. Then we see the empty cars data, and then at the end, you see, oh, okay. Then I made a mistake. This should be not and. This should be or. Sorry. Yeah, it should be or. Yeah, because if and it cannot be two values because it's intersection. But this is or. With or operator, this is the or operator. So this one, this value, you write your alt, I think, your alt key, and then the one next to the shift. So you have this. This is called or operator. Then if you run this, now it should be fine. Okay, I made a mistake in my empty cars. Somewhere a spelling error. So this one is empty cars, correct? Empty cars. Okay, here I made a mistake. Empty cars. So now if I run this, it should be fine now. Again, I have a spelling error somewhere. Let me check. Where is it? Not empty cars, empty cars, empty cars. Here. Okay, this one is again making another mistake here, another error here. So it's this, you can run it here. Now it should work. So if I run here, so you see variables are correctly labeled. So if we want, we can check table empty cars HP cut, for example. Yeah, like this. We don't have high. That means I must have made a mistake here. Less than okay, else if there is an error. So you see HP. Yeah, now if I run it, it should be correct. Okay. Okay. As if empty cars HP high greater than 200, and then what is it saying? Unexpected else in medium. Okay. Else if empty cars HPI greater than or equal to 150, maybe let me take this to this. Empty cars HP. Once bracket here, then one is closed. Empty cars HP cut medium. So again, else if empty cars HPI greater than 200, that means empty cars HP cut I will be assigned as high. I can't see my error. So now it should be okay then. No high. Then probably we don't have, okay, but we have values greater than 200, didn't we? So let me check. Okay. where is my summary? Or max, the maximum value of, oh no, 335. So it should work somewhere. Then I must have made something wrong. Okay, else if empty card HP high I greater than 200. Okay. Yeah, so, I mean, it's again needs to be if, else if, else if. I don't get it. That's weird. Okay. Greater than or equal, less than 150, less than or equal to 200. Low and medium. But why is 200 here now? Less than 150, greater than 200. Okay, maybe let's ignore this and then see if it works. Let me delete this part of the code, then we will have only okay, this part, and then see if that was okay. But why? This was the output that I was looking for. This is weird. Okay. Now it's working. But where is medium? No, it worked. Yeah. Low, medium, okay. Okay. Empty card HPI, HPI, HP. Run it. Here. Okay. Okay, now it's saying high is only one value, but that's not true. I don't think that's true. So this is between 150 and 200, and that's I'm assigning it as medium. Okay. If I do it again, yeah, okay, then there is an error somewhere. What is it saying? Unexpected. Yeah, okay. Where is it? Here. Like this. One curly brace, one curly brace here, one curly brace, one curly brace, and another curly brace here, one curly brace, one curly brace here. No. Okay, where is it? Let me scroll this up. Now it should be else if, not else. And now doesn't seem to be working, but let me check this one again. Like, oh, okay. And then no, this is not what I want. Yeah, anyway, this is how recording works. For some unknown reason, I must have made some error somewhere in these brackets. But this is how you record your variables in if you want to do like base R from numeric to categorical variable. At the same time, you can also do let's say low to 1. You can also assign low values, like if the variable is low, you can change it to 1 if it is, or you can also do this way. Let's say no, this is if I want to identify the values. Let's say if I want to identify empty cars, HP greater than 100 or HP. So if I want to do this, I will identify the values. So this is how they are. Yeah, here they are. This is if you want to filter it. If you want to filter your values or your data based on the values of the variables. Yeah, I think we need to call the station now. Maybe I can look at it again, and then I will let you know where was. But I mean, you may not need this. Actually, you don't need it because it's so easy to do it in dplyr. You can just use the case when, and then you can easily record all the variables. I mean, also if else also can do this, but I just wanted to use for loop with if else. Otherwise, it's kind of tedious. It's a long way of doing it, but you need to know it. But if you want to know it, you can have a look. But there are also you can also look at like here help page. You can just write help controls, then it's control, and then it gives you all the explanations for loop. So it gives you here. So if you scroll something here, and then it gives you every how it's written, what is that, and it's a control flow. So you have if else and for, and the while loop is also, for example, here. Let's say if we run this example, for example, you can just take this, the next one, let's say if you copy this and then try this, yeah, this is okay, I forgot the other bracket, and then you can type this, enter. Okay, I have made a mistake, so again I need to run it again. Then you see this, then I can also do, let's say instead of this, I can do histogram, hist x. Figure is too large. I think my RStudio is having problem today. I need to find out what is happening, or maybe because I'm, yeah, okay, that's why. Yeah, so it's displaying. I need to, yeah. I think this one we will look at it again. This is the law of large numbers. That means if the number is getting, it's a random, it's picking up a normal distribution, like you can use our norm, let's say 100. Then you see histogram, so it will pick up the number R norm. Okay, sorry, no, not R norm. So you can use this, and then so I already have that. So it's R norm. 100. But if you can use 100,000, so look at this graph. This graph doesn't look normal distribution. I mean, it's normally distributed, but it's not as nice as this one, for example. I mean, look at it. And then if you have like, let's say like this, and then it goes more nicer, normally distributed. You can randomly generate this way. You can randomly generate data. Let's say if you want y, let's say x equals r norm 1000, and then if you want, you can also say y equals x squared, 100, maybe 1000. Then you see, then you can, yeah, now we already have that. But if you want to plot, for example, plot x, y, so it should be, what kind of graph do you expect? Something like this. So it could be like this. So if you apply linear model, for example, for this kind of graph, then it doesn't work. So maybe you can also do x squared, maybe x polynomial. Let's make it polynomial. x3 plus x squared plus, let's say, I don't know, 3. Then you do this. X squared, no, x squared is like this. And then if you make it a relationship, okay, plot x, y. Yeah, it goes like this. Maybe if you, let's say, if I minus x cube plus, no, not like this, minus 2x. It's like, let me do, what was this, parabola, x squared plus, in this kind of polynomial, 3x plus 1. And then, yeah, something like this. Okay. So, yeah, that's how it looks for today. For next time, we may do like filtering, reading data, yeah, and then we go one by one, recording, categorizing your values, and yeah, and then yeah, we do again. Okay, so that's how it is for today. Hopefully we may have another session again. Thanks.